last but certainly not least, Dr. Ido Sella. Ido is a professional biologist with over 8 years of experience in the field of marine biology and ecology. Dr. Sella is the primary inventor of a number of biological innovations that mitigate human impacts in urbanized shorelines. ECOncrete technology provides sustainable solutions for construction of ecologically active infrastructure. Dr. Ido Sella.
Thank you for having me. Now for something completely different. We, as opposed to the other companies that are showing here, which are operating in an environment of high tech, we're working in the lowest of the lowest tech there is. We are working in an environment where the product's supposed to last for 60 to 100 years. And we are launching products into a market that the validation time and the expected acceptance time of getting a new technology into the market is not measured in years or in months, but in tens of years. And one of the most important things is to show your technology is validated. And in our case, it's taking more than 2 years just to show that our technology is working. So what we do, we are marine biologists, environmental engineers. In my last company was Tel Aviv University. We all came straight from the lab, finished our PhDs in marine biology, working underwater in the lab. So we have no experience in business development. We opened the company didn't have any clue about concrete, and we got into concrete completely by accident. What we do is develop a technology that can harness natural process for creating coastal infrastructure, which is concrete-based, that are more resilient and stronger, getting stronger with time, and actually act as a natural reef. And we'll start with a short biology lesson. So coastal water is the most rich and diverse ecosystem in the world. But 60% of human population is living along the coastline, and they require infrastructure. And 70% of coastal infrastructure, if it's ports, if it's jetties, if it's breakwaters, if it's seawalls, are concrete-based. And concrete is a very, very poor surface for what we call colonization of marine organisms. And this takes us to two problems. One is the chemical properties of concrete is very basic. It's the pH of seawater is 8. The pH of concrete is going up to 13, which means that the little baby coral that swim in the water and touch concrete surface is actually getting burned. And it's taking concrete something like 60 years to lose this basic surface and to start to promote biology. And that's the reason we only see biology, a healthy environment developing on concrete surfaces only after a lot of years. And we usually see two options. One of them, which is very typical, is what you see here on the right is a concrete cube that stayed in the Red Sea in front of the Marine Lab in Eilat in Israel for more than 25 years in the water. And it's looked like someone put it in the water yesterday. And this is not an ordinary environment. This is the highest biodiversity in nature. Sorry. And it just not getting covered by corals because they could not stay on the concrete. On the other hand, what you see here is a seawall from the Great Lakes, the place that we are testing our technology, and they have an invasive species problem. And these zebra mussels are actually covering every surface. So nobody can sit on concrete unless you're strong enough, and invasive species, those are species that penetrate into the environment and they make use of surfaces which are not occupied by other species. So they get completely, the seawalls there, they are concrete-based, get completely covered by this zebra mussel, which create huge damages in cost for infrastructure. So what we do is we develop a technology that we can modify the chemical proportion of the concrete and make it suitable for colonization of biodiversity and a lot of species. And those species, what they do is they take they put their skeleton on the surface of the concrete, and they actually create a reef, a biogenic rock that grows on the concrete and encapsulate it and protect it with time. What you see in the middle is our concrete when you put it in the water, and 12 months later, this is an experiment that was running along the east coast of the United States with, at all the NOAA sanctuaries, working together with NOAA. And we can see that we can get to a cover of calcium that grow on the concrete and close it, completely seal it, and protect the infrastructure. What we do is we address issues of composition of the concrete, the texture surface, the microtexture of the concrete, and later on also design. So we get to a system or infrastructure that have enhanced ecosystem services, but at the same time have bioprotection capabilities. We're protecting the infrastructure with the biology. Our business model is straightforward. We add salt and pepper to the concrete mix that change the properties of the concrete. We're not affecting any of its structural performance. We work with the clients and we get them the forms or the precast units themselves, and we're involving in consulting of the project and from the beginning. And our market is worldwide. What you see here on the right is the statistics. There is increased storminess in the coming future, sea level rise. Urbanization is moving more and more into the shoreline, so the market is actually there, and in the last 5 years, unfortunately, what we see is that 100 years storms that are supposed to come every 100 years, are getting, there were 3 in the last 15 years. And how do you launch a product like ours into the market? Slowly. Very slowly, and this is the way we started. So after we did a verification, and after we did the research and development that took 2 years, we knew that we have concrete mix that work good, so now you need to show that they perform. And what we did is we teamed up, sorry, everything is running. We teamed up with the Army. They built a new port in Israel, and the Army actually used our technology to create the bottom part of their breakwater for this new port. And we actually showed that in 2 years, those are our units on the top. The lumps that you see are oysters. They're starting to cover the concrete. So we create a unit which is structurally reinforced and creating the breakwater, getting strong with time, and filter the water within the port. So this was the first project. Everything was published in peer review. We came from the academy. The thing that we know how to do is write papers. So on every project that we do, we write a paper. What happened that the data from this project brought us into what we're doing extensively in the last 2 years, and this is this project, which, as I say, our market is created by storms. The biggest storm that was there was Sandy. So after Sandy hit the shorelines and the bill for the rehabilitation of Sandy, the Sandy region came out, one of the things that came out are they're looking for new technologies. Our technology was chosen to be a core technology in a winning project that got funding of $60 million from federal funding now went into the state of New York. And we're actually a part of a team that built breakwaters at the tip of Staten Island, protecting the town of Tottenville, which got hit quite massively during Sandy by surge and by wave. And we actually working on a breakwater system that grow with time and have the ability to get covered with oysters. And actually oysters are always a few feet below the high tide, which means if there is a sea level rise, the oyster can accumulate one on top of the other and create a biogenic rock on top of the breakwater. So it's a breakwater that's supposed to become a reef with time and attenuate the wave that's going to affect the shoreline. The stretch of breakwater is 2 miles, where our technology is between 10% to 20% for the entire project, for the entire structure. But in order to get to that point, in order to make our product more familiar with the environment that we are working with, we teamed up with the City of New York, with the state parks, the New York Park system, and we actually started to incorporate our technology into existing products and projects. One of them is the Brooklyn Bridge Park. It's a park on the Brooklyn waterfront, and there we created a revetment system that supports the park, but it's actually biologically active. So instead of just putting rock, we put in our modified concrete, and very fast we can have fish larvae there, oysters, crabs that were not seen in the area for the last 25 years came back in simple units that are made of concrete and support the shoreline. And we do the same on marinas, and this is, for example, a product that we're developing here for the Florida market. Those are seawalls. Seawalls that get covered with biology and filter the water in the marina. We can do it right now, and this is was installed in Tel Aviv, but in Herzliya, but is now in the process of being installed in Key West. And this is how we actually got into a large project, and this is something we never thought about. It's a product that came from the clients, become one of our biggest sellers, and it's all starting with worms. So when we showed our technology in New York, one of the leading companies, a marine engineers company, manager came to us and said, well, it's nice and it's very nice, your technology, but we have a huge problem here. The water quality on the Hudson River went up. Everyone is, because of the Clean Act water, everyone is happy, but who's really happy are the marine boars. They came back. And the entire coastline, the entire waterfront system of New York and New York is based on wooden piles. And those wooden piles that were, for the last 40 years, the water was so toxic, so there was nobody to damage those wooden piles, are now eaten by marine boars. And because they are getting rotten and full of holes, and what you see here on the right is a slice of one of those piles that hold the piers, they got completely eaten by worms. So the system is now to encapsulate the wooden pile with a load-bearing system made of concrete that become like actually a concrete pile. And this is the massive market there, and they were asking for our solution. And what we did is in 6 months, we adopted our technology to be cast underwater. All the casting is done by divers. We developed in Israel in 3.5 months a system of forms that can be attached to the piles underwater by divers. And we actually initiated a project of replacing the existing technology with our technology and creating pier piles which are stronger. The divers from the union can cast them really easy on the same method that they cast any other concrete structure there, but also gets stronger with time and get a cover of biology that protect them. That's my sting. So I'll run a bit ahead, and I'm going to show you this thing. And this is the last thing. We're doing mega structure. But at one point, we understand that we need to shift the system and how we approach the market. And what we did is we teamed up with leaders in the industry. And one of the leaders of the industry is Besser Company that said manufacture machinery for concrete casting. And we teamed up with the project with them in order to take our technology to the next step, and this is to mass production and to be a commodity. And the first product for this joint venture is going to be installed this August here in Florida in Nova University in Fort Lauderdale. And those are actually units for creating, to stop beach erosion. And they are made by block machines, like the most common machinery for concrete casting. And it's actually taking us to the next step of getting our technology available not on a project base, but actually for any client that want to build a seawall or any municipality that want to use off-the-shelf product. That's it. Thank you.